So Manacher's algorithm gives you the linear time algorithm to calculate the largest palindrome substring in a string. So brute force would be O of n cube optimizes O of n square with dp, and then Manacher's algorithm would do it in linear time, right? So first things first, this algorithm works in a way that we first select a center and then we expand around the center, seeing this. So as you can see, this expansion around the center will only work for odd length string. So then what to do with even length string, right? So we'll modify this even length string as well. So we will append any symbol which is not being used in the string after every character and before every character. So basically hash here, hash here, hash here, hash here. So if hash is not being used, you can use hash. Other than that, you can use anything, right? So if you see, this string will become this and then this string will become this. So if you do this, the expansion thing would be so the like this even string length would become the odd string length, and odd string length will remain odd string length, right? Now how this algorithm works, right? So first what we'll do is, the gist of this algorithm is let me explain this properly. The gist of this algorithm is, you don't have to repeat your processing anytime. So basically I'll explain what I mean to say here is so basically, let's say you have A, B, C, D, E, F. Oh, sorry, not this. Sorry. Let's say, let's take simple example. Let's take this, right? B, B, A, D, right? Now let's say you are at this one, right? Let's say you are at this one. So let's explore this, right? So let's stay at this. So basically, if you expand around this, how many palindrome you will have, right? Nothing. So one length is there, right? One week, if this would be 0, right? If you expand around this, you will get 1. If you expand around this, there is nothing. So 0 length palindrome, right? There, if you expand around this, you will get 1 length. So this and this, and then this, and if then you compare this. So we are capturing length of palindrome only at one side, right? Then this would be 1 only. Then if you expand around this, right? So if you expand around this, let's see, this, then this, then this, and then this, right? So you get how much? 1, 2, 3, 4. So 4 length is around this, right? So then you'll get 4. Now the good case comes, right? Now the good case comes. Let's see. So let's make a vertical mirror. And let's get the image of the vertical mirror. Cancel. Vertical mirror, and then let's get this. Cool, right? So done, huh? So let's say, okay, cancel. Okay, sorry. Where is the selection tool? So let's say, right now we have kept this mirror here at the center, right? Let's say we have kept this mirror at the center, huh? So look, now you have to process this, right? Now you have this mirror at the center and you are looking to process this. Would you see all this expansion and then this and then this? Aren't you doing a repetitive thing? Because let's see, right? Since this hash processing has ensured that till this point you have, and you anyways have a palindrome. That means that mirror image of this B, by looking in this mirror image of this B, that is this, has already been processed, right? And if it has been processed, you can actually look at the palindrome length here, which is this and this, and then actually check after this. So you don't have to do one length of palindrome checking, because it's anyways the mirror image of this, right? And you are inside this domain, like inside the right bound. This is inside this right bound, so that means that this mirror holds true for this index, right? And now if this mirror holds true for this index, that means that the mirror of this B is this, which means processing of this has already been done. And processing of this is already been done, we can actually utilize that processing. That means that we can straightforwardly say that at least one, which is this, at least one is there, at least one length palindrome is there. Now we will, after this we'll proceed here, right? So what we'll do is, this check is already there, now we won't check this, and then now we will check, okay, centering at this and this, do they match? No, right? So we can proceed ahead with this. So this pre-computation thing we are utilizing here. So using this, right, let's write the code for this. We probably can add D as well. Have we added D? Yeah, we have added D. So initially, your rightmost bound of largest palindrome you have considered is R. Your center is C, right? Now, and your current index is I. So now you will first check whether it has been pre-processed or not. How we will check? You will check finding out its mirror reflection. So mirror reflection is equal to 2 times of the current center minus I. Okay, so this is the basic formula to find out the mirror reflection. Now if your current index, so basically if this is under this bound, right? So sorry, so if I is less than R, right, if this is under this bound, then we can actually say, okay, we have already pre-computed minimum of R minus I comma P of mirror, which is M, right? And in P we are storing the largest length of the palindromes, right? So P stores the length of the palindromes. So P of N is initialized to 0 initially, right? Now since we have checked, now we are good to go and check, while what we can do is centering, let's say we are centered around this, right? So we'll check this, right? So centering around this, I plus P plus I plus 1, whether it is less than length of the string, and I less than P minus I minus 1. So this corresponds to this corresponds to this, right? If they are within the array bound, then we will compare these. So S of I plus P of I plus 1 is equal to S of I minus P of I minus 1, right? Then we will increment. So till this point we have encountered this, right? Now what we will do? Now we will do is, we will check, did we get a largest palindrome? Did we get a largest right bound of a thing, right? So if I plus P of I, this gives the new right bound, right, of centered at I, is if it is greater than the current right bound, change the right bound to I plus P of I, and new center would be I, right? So using so for each I we will be iterating over the length. This would be here, right? This will give you the exact thing, and view what you are doing is this, right? This small block is actually saving us. So this small block is saying that, okay, at least mirror length of computation has been processed. So you don't have to do that. You have to just do the other computation, further computation after the mirror one, right? Because mirror has been processed already. So you are saving that much of computation, and then average case scenario comes out to be order of n. Cool. Like, share, and subscribe.